Well, hello guys, welcome back to Mr. G Physics. Here's Mr. G, and this time we're going to be doing another question for the grade 10, 11, as well as 12. But are you struggling with electric circuit? Well, don't go. Stay here because we're going to solve a question on electric circuit. And electric circuit, guys, believe me, is one of those topics that make the children worry. It's difficult and they struggle a little bit. All you have to do is to thumb up, like the video so you can get more videos like this. You subscribe for the channel so you can get all notifications and videos I post on regular basis, and then I'll go into the question. This question was question 9 done in the Gauteng province in 2023 in the grade 11 question paper. It's a quite good question, so let's dive into it. The question says, study the circuit diagram below where the battery has an EMF of 15 volts. Ignore any internal resistance and answer the questions that follow. Internal resistance, do not get intimidated by it. That one is going to be in grade 12 and eventually you are going to be there. In the grade 12 you will work with internal resistance. It's nothing to worry, it's not that of a difference. It's just that the battery will have resistance inside, and obvious the EMF will drop. The EMF will not drop, the potential difference will drop when the circuit is in it's working, but this is not the case. There is not internal resistance, and as you can see, the switches S1 and S2 are open, both of them. Therefore, the potential difference that B1 is going to read is equal to 15 volts. There we go. There is not internal resistance, so when the switches are closed, that potential difference remains like that. The question says, state Ohm's law in what? And Ohm's law states that the potential difference across a conductor is directly proportional to current in the conductor at constant temperature. Now, what is this in symbols? You will write it like this. V is directly proportional to I if T is constant and R is constant. So for the same R, the potential difference is directly proportional to the current. Now, what I want you to show you here, in the exam, they give you the formula, but you have to be able to read. The formula that they are going to give you is in this specific way. So this formula like this, you cannot read because it's not Ohm's law. You have to rearrange in terms of potential difference. So if you rearrange that formula, you will get the following. Potential difference is equal to Ri, or let's write per half IR. And from here, if you read carefully, you can say that potential difference is directly proportional to the current if the temperature is constant and obvious for the same resistance. That is Ohm's law, guys. It's 2 marks. You have to learn the law. Nothing to say. Just learn it. It's not that bad. Identify the resistor that is not an ohmic resistor. So let's have a look in terms of ohmic and non-ohmic resistor. So let's make a small note here for that specific question, and after this you should be fine for that explanation. Resistors, or perhaps conductors rather than resistors, let's write conductors as a general, are divided into main groups. Those are ohmic conductor and non-ohmic conductors. Conductors could be either ohmic and non-ohmic. Guys, it's not that bad. The ohmic conductor does obey Ohm's law. Nothing to say. Now, why will that be? Well, because temperature is constant. Temperature is constant, and if temperature is constant, so that's resistance. Remember, resistance depends on temperature. If temperature changes, resistance does change as well. So that is why certain conductors are obeying Ohm's law, and we call them ohmic conductor. But there are those conductors that do not obey Ohm's law. There are those conductors that do not obey Ohm's law. Now, why will that be, guys? Well, it's easy. Because temperature, I don't know what I was going to write in there. Temperature changes. If temperature change, resistance change. I want you to know that resistance is straight related to temperature. If the temperature changes, resistance will change, and therefore Ohm's law will not be obeyed in this case. Examples of here is going to be the light bulb. Light bulb for a short period of time will increase the temperature, and therefore it does not obey Ohm's law. Now, note the following: if the light is working for a long period, the temperature remains constant. It doesn't mean that it's going to change all the time and it's not have a limit. No, light bulbs, the temperature increases for a certain period of time, then the temperature will remain constant, and thus therefore the resistance will remain constant as well. So if we go to the question, we have a light bulb there. So the answer is the light bulb. And they gave you 2 marks just for saying the light bulb. You just have to identify, which is quite simple. Give a reason for your answer. Well, yeah, guys, we just explained that one. So you can just say that temperature change, so resistance also change. So I hope so far so good. Question 9.4, with only switch S1 closed, calculate. And now let's have a look to the circuit. They are going to close S1. So what is going to happen? The circuit will have only one path for the current, guys. This becomes a series circuit. This R here that we don't know won't work because the switch is open, so the current won't flow that way, so all the way up until this. So everything is in series. It means that the total resistance of the circuit at that moment is going to be only the series resistance. So we can actually say, and this one is going to be for question 9.4.2, that R total is equal to Rs. Guys, which one is Rs? You add the resistance. We have 3 resistance here. We have 5, we have the 15, we have the 10. Now note, now you will say, but sir, we cannot apply, this temperature will change the resistance of the light bulb. No, I said the temperature will change for a short period of time, okay? So then eventually will remain as 15. So all we have to do here is to add the resistance. All of them. Remember, resistance, you're going to add. I don't know, I'll recommend you maybe to write R1 plus R2 plus R3 before you substitute. Then you say RT is equal to 2, and then you substitute is 5 plus 15 plus 10. And that is equal to 30 ohms. So the total resistance of the circuit is 30 ohms when S1 is closed and S2 is open. And they gave only 2 marks. 1 mark is for this substitution and 1 mark is for the answer. Now, this time they gave 2 marks. It doesn't mean that they're always going to give 2 marks. Maybe next time you see a question like this, they'll give 3 marks, 1 for the formula as well. Now, calculate the reading of the ammeter. So let's go into look the ammeter. What is that ammeter reading? That ammeter is reading the total current of the circuit. So this one is reading the total current of the circuit. Okay, so how are we going to use it? We are going to apply Ohm's law. I'm thinking of Newton right now. So we're going to apply Ohm's law. Now, Ohm's law, I recommend you to write the formula exactly as they are given to you in the exam. Okay, so if we move to the formulas, here they are. This is the formula you're looking for. So I'll write it in that specific way. And I will tell you just now why I do that. So the question is a 9.4.2 and it's a straightforward Ohm's law. So it's R is equal to V over I. Now, what I do this one is because if you rearrange and you make a mistake, which anyone can make a mistake, you lose all the marks. So that is why I like to write it exactly as it is in the formulas, and then I substitute just like that. So the resistance is what we got, which is 30. The potential difference is the total one, which is 15, and the current is going to be I. So when you rearrange this one, you get that I is equal to 15 divided by 30, and therefore current is going to be equal to 0.5 amperes. That is the current And then marking wise is quite simple. There are 3 marks. So one for the formula, one for this substitution, one for the final answer. Quite simple, that specific question. If we move on, they say the reading of V2. Now, V2 is reading the potential difference of the 10 ohm resistor. So, well, maybe the way in which that voltmeter is connected will confuse you, but it's quite simple. That voltmeter is reading the potential difference for the 10 ohm resistor only. So that is what is the question here. And once more, we have to use Ohm's law, but we are going to rearrange eventually, and that's it. So now here, this one is question 9.4.3. Now they say potential difference, calculate the reading of V2, that is the potential difference for the 10 ohm resistors, as I just said. So what we are going to do, let me move this one a little bit there. We are going to calculate potential difference using Ohm's law. So guys, once more, I am going to write it as it is there in the formulas. But this one is only for the 10 ohm resistor. So that is important to have in mind. I'm working and I'm going to apply only for the 10 ohm resistor. However, the current is the same, because remember, in a series circuit, the current remains the same. So the current that flows through the 10 ohm is the same as the 15 ohm and is the same as the 5 ohm. All of them will get the same current. So saying that, resistance is going to be 10, potential difference is what we are looking for, and the current is going to be what we just calculated. Whatever answer you get, that is what you have to substitute in here. That is called positive marking. So when you rearrange, potential difference is equal to 10 times, let me just fix that one, I'm trying to save a space, 10 times 0.5, the answer for potential difference is 5 volts. 5 volts, that is the answer. Another very easy question here. Okay, so it's 5 volts. Now the marking is one for the formula, one for this substitution, one for the answer. Now guys, don't take me wrong, be my guest if you want to write the formula in already say V is equal to IR. That is correct, you will get full marks if you do that. It's not the problem. The same here, you can write I is equal to V over R. It's the same. It's not a problem. It's not an issue. It's just that sometimes people attempt to make a mistake. Okay, but it's fine if you do it that way. Okay, so I hope this one is clear up until here. We already now are done with question 9.4. Now the question says switch S is now also closed. So they switch, no, let's rather say they close S2. So now the circuit changes. Circuit is not anymore in series. You have a series and you have a parallel connection within. The 5 ohm and the 15 ohm are in series, and I'm going to mark like this. This is in series up until there, but here current split little bit. That is what you need to note at this specific point. What will you observe in connection with the brightness of the lamp? Choose from increase, decrease, or remain the same. And let's have a small note here in terms of this brightness of the lamp or light bulb. Small, very small note here. The brightness is straight related to power. All right. Power is the power of that specific light bulb is the one that affects the brightness of the light bulb. And this one, the formula for power that we can apply here is current square multiplied by the resistance. If you notice, R is constant. So the power will depend on what happened to current there. Now note, we are adding a resistor in parallel. In a previous video of mine, I spoke about what happens if you add more resistors in parallel or less resistors in parallel. But the thing is, if you increase more resistors in parallel, the total resistance of the circuit will decrease, and therefore the current will increase. So that is a note, guys, you have to write somewhere. Maybe I will write it here again. And I did put the note once more here. The more resistors in parallel, the smaller the total resistance, the greater the current. So if current increases, power will also increase, and therefore the brightness will increase. So the answer here is increase. There we go. That is the correct answer. Increases. So the brightness will increase. Give a reason for your answer. Well, guys, I just explained here what is going to happen here in this specific question. The next one. Well, the next question said calculate the reading of V2. Now remember, the reading of the meter is going to be 1.2 amperes. They're going to give us the reading. They gave us the reading of the new reading of the ampere, of the ammeter. So now V2, we're looking for V2, which is reading the potential difference of this parallel connection. So let's take this parallel connection as a unit. So if you remember from grade 10, you know that the potential difference in series is the addition of the potential difference. So if we take that resistor as a unit, we can say that the resistance, potential difference, Mr. Gomez, the potential difference total, which in this case is the EMF, all right, is going to be equal to the addition of the potential difference of all the resistors. So that will be potential difference of resistor 1 plus potential difference of the lamp, I'm going to call it lamp, plus the potential difference that is go through the whole parallel connection. This is one way of doing this specific question. And then all you have to do is to calculate the potential difference for each of them. Remember, resistance is equal to current divided by, potential difference divided by current. You see what I'm saying? You can make a mistake. It's quite easy to make a mistake. So this one, the resistance is 5. That is for the first one. Potential difference, what we're looking for. Current is going to be 1,2 because it's constant for all the circuits. So the potential difference is equal to, so this potential difference is 6 volts. For VL or the lamp, we repeat the process. All right, now there is a problem. The EMF of the battery is equal to 15 volts, and we have already that the potential difference that is go through one of the resistor is greater than the EMF. So there is something wrong. Now I understand why the learners were concerned about this specific question. I noticed now, so I backtrack the question and I noticed that they make a mistake in the current. So there was I guess a typing mistake in the current, and then it cannot be 1,2 amperes. This current does not increase all the way to 1,2 amperes, but rather to 0,58 amperes. That is the new current after we add that resistor in parallel. Note the following: the initial current is 0,5, so this current for sure must be greater, but well, how big? It depends. 1,2 current is a little bit too big, and when you do the calculations, you notice there is a mistake. So this one, it is wrong because of the substitution. So what I'm going to do is I'm going to resubstitute the correct one. I'm going to, the current is not 1,2, it's rather 0,58. And then therefore the potential difference here is another potential difference, which is 2,9. This is equal to 2,9. Guys, this is why I do not recommend learners to study from memos. Maybe this question paper came with an errata that we don't have access to it or things like that, because you don't know what is going on there. Sometimes there are mistakes that you don't notice, and then you may struggle or think you are working confused. So this one is not 1,2, it's 0,58. And then when you do the calculations here, you get that this one is equal to 8,7 volts. Now we are talking about. So now we're looking for the potential difference in parallel. We have everything So the only thing we have to do is to substitute for this specific equation. The potential difference of the battery, which is the EMF, is going to be 15, and this is equal to 2,9 plus 8,7 plus VP, which is what we are looking for. Remember, we are looking for this one here. So when you do this calculation, which is a very easy calculation, guys, you will get that the potential difference of the parallel connection is going to be equal to 3,4 volts. Note, this potential difference is going to be the same for each resistor. Hey, resistor R first. Resistor in parallel. That is important. Potential difference is equal in parallel. So guys, if you do this question, which I am sure you make a mistake, if you do this question, then you will get 1 mark for calculating the potential difference of the 5 ohm resistor, 1 mark for calculating the potential difference of the lamp. You will get 1 mark for calculating the final potential difference, which is quite simple. I hope you understand. I will fix it for the learners when I put it in the description below the video. And well, the final question of this specific question is calculate the value of R. So we're looking for R there, which is not of a big deal, which is not a big deal really. Now this is question 9.7.2. There are different options to do that resistor. One of them is using Ohm's law. In both of them, we have the potential difference. We calculate the current for the 10 ohms, and then we have the total current we subtract. That may be the fastest one. The other one is using the total resistance. So I'm going to do the ones of Ohm's law and maybe give you a hint for the next one so you can try to do it by yourself. So we may calculate the current that is passing through the 10 ohm resistor. That is equal to potential difference divided by resistance. Remember okay, you know what, let's write it because I want to have consistency. So resistance of 10 ohm is equal to potential difference through the parallel connection divided by the current that passes through the 10 ohm resistor. All right, we're trying to look for the current that passes through the 10 ohm resistor, which is that one there. So the resistance, if we substitute, is 10 is equal to the potential difference in parallel, which we calculated, and 3,4 divided by the current for the 10 ohm resistor, which is what we are looking for right here. If we rearrange this one, let me take a new page, even though I'm not going to use it at the moment. Current of the 10 ohm resistor is equal to 3,4 divided by 10. And then you have that this current is equal to 0,34 amperes. Now, for the other one, we need the current for the R that we don't know. How we do know that? Total current is equal to the current that passed through R plus the current that passed through the 10 ohm resistor, because they are in parallel. The total current will come here and will split in two parts. One of them will get this amount we just calculated, and the other, or the rest of the current, will go through the other resistor there. So this current here, remember, is 0,58. 0,58 is equal to resistor or current of the resistor R plus the current through the 10 ohm, which is 0,34. So that is what we have. The current that passed through resistor R is equal to 0,24 amperes. From here, we once more use Ohm's law to calculate R. R is equal, and let me maybe change the color. R is equal to potential difference that passed through R, or the parallel, which is the same, the parallel connection, divided by the current that passed through R. All right, so capital R is equal to potential difference, we just calculated 3,4 divided by the current that passed there, which is 0,24. So the resistance R is equal to 14,17 ohm. Guys, this is the end of the question. Now, Alternatively, this question can be also done by using the total resistance of the circuit. And let me just give you a hint. Now, for that one, we have to calculate the total resistance of the circuit. So R total is equal to V total divided by I total. If we do this one, guys, V total is the EMF, which is 15. The current, remember, it's going to be, I keep forgetting that one, 0.58. And then you'll get that the total resistance of the circuit is 25.86 ohm. Now this is for the total resistance of the circuit. From here, remember that R total is equal to RS plus RP. So with that in mind, we may calculate the resistance in parallel. From here, the R total is 25.86 equal to resistor in series. Now resistor in series, we have the resistor of 5 ohm right there and the 15 ohm. Those two are in series. So in other words, is 20. I'm going to write 5 plus 15, but no, it is 20 plus RP. So if you do this one, you get that RP is equal to 5.86 ohm. Alright, so now what we do with that one? Well, guys, we come to either one of the two formulas for resistors in parallel we can use here, which are the following. We can say here that R in parallel is equal to R1, R2 divided by R1 plus R2, or we can say that 1 divided by R in parallel is equal to 1 divided by R1 plus 1 divided by R2. Either one of the two formulas can be used. All right, just for the purpose, I'm going to use the second one, and then we're going to calculate R. So this one is going to be equal to RP, which is equal to 1 divided by R plus 1 divided by the other R, which we have the value here. So if you substitute, you have that 1 divided by RP. RP is 5.86. This is equal to 1 divided by R plus the other resistor was 10, so it's 1 divided by 10. So when you rearrange this one, you will get that 1 divided by R is equal to 1 divided by 5.86 minus, this is a minus, let me erase that little dot I placed there, minus 1 divided by 10. Guys, R is the denominator, so it's going to be equal to 1 divided by 5.86 minus 1 divided by 10 to the minus 1. The resistance is equal to 14.16 ohm, which is the same answer. We are done. All right, so this was a hectic question because the fact that there was a mistake in the current of the circuit. I will make a note in the description below so the learners can notice and solve the question. Guys, thank you for watching. I hope it helped. If it helped, thumb up. Doesn't cost a thumb up. Subscribe for the channel, and then I'll see you next time. Mr. G